All right, so we're gonna start chapter 5 today. As you can see, like this is a little summary of what we're gonna be doing, what we started doing. So what we started doing is based on a pattern. Based on a pattern, we can do a table, we can do a graph. Right? Based on a word problem, we are able to write the equation. Given a table, we can figure out the difference and then plot the points and make a graph. Based on a graph, we can come up with the equation. And lastly, given an equation, we can do a table and we can do a graph. So by the end of the chapter, you should be able to do interchangeably everything. Okay, so that's the purpose of this chapter 5 and chapter 6. So, what do you notice about page 2, 3, and 4? Yeah, we did it already. So, wow, just like that, we are on to page 6. Okay, so I just forgot. I don't know. When I sent this to print, I guess I had duplicates. Okay, so I put it in the um I put it in chapter 4 and 5. So don't worry about it. You can skip those pages. We are on page 6 right now. Page 6, page 6, page 6. Okay, so with these graphs, what is this axis called? X-axis. And when this one? Good. In a coordinate, it always have a, is it y and x or x and y? X and then Y. Make sure you don't mix that up because you've actually learned how to sing the alphabet song since you were a baby, right? So M N O P Q R S T U V W X Y Z. Okay, so you know it's X and then your Y. How many of you played Battleship before? Do you guys like that game? Okay, so this is like Battleship. So X and then Y. So X value is 6, Y value is 3. So this coordinate has the value of 6 and 3. Okay, then what would this one be? What would E be? Anybody? Let's say Joshua? 4 and 0. Good. Then what about you, Owen? What about this one? 0, 2. Good. So notice whenever it's on the axis, one of the numbers have to be 0. Right? So if I were to plot, then what if I were to plot -4 and 3? So -4 will be here. 3 is the y. Where did they cross? Right here. You sunk my battleship. Okay. So this is how you write coordinates. When you write coordinates, make sure you have brackets as well.
Tatum Village to the main office immediately. Tatum Village to the main office immediately. Thank you.
Okay. How many of you learned quadrants in grade 8? Good. Okay, so Kevin, which quadrant is this? Yeah, quadrant 1. We use Roman numerals for quadrants. Alright, what would this quadrant be then? This quadrant? Yep. Sorry? Quadrant 2, yeah. So you go counterclockwise, and then this is quadrant 3, and this is quadrant 4. Quadrant meaning like this area. So any points in this area. So for a point that's in between, it's not in quadrant 1 or 4, it's on the axis. Right? So then for example, this point right here is what's the coordinate of this point then? Let's say Nathan. -5, -4, and which quadrant is it in? Quadrant 3. Good. Okay, so if you were so good and you did the asynchronous work over the weekend, this was a little puzzle that if you put in all the letters from the coordinates, you will solve the puzzle with what did one year say to the other. It is a very bad joke. Okay, and I did not make this joke. Okay, so if you want later on, you could try it. Okay, you can see what your left ear said to your right ear. Okay, next we're gonna move on to page 7. Okay, page 7. Okay. Uh, so so now I know in the past your teacher always gave you guys the scale and nice and neat, and then all you had to do was draw the bar graph or plot some points. But what if now I just give you a blank grid? Okay. So we need to figure out what's a good scale. So just like what we said, x always comes before y. So same thing with table. Your first column is x, second column is your y. So Johnson, looking at the first column here, what's your minimum and maximum number?
0.
0 to 10. Good. So I have my x-axis here. Can I fit the number 0 to 10 here? Yeah. So what's a good scale to go up by? So go 2, 4, 6, 8, 10? Ones. I can go by ones. So like I can do like 1 for I get what you mean. So you could say just 1, or you can say 1 every 2 bucks. Okay. You can just say 1 if you want. Doesn't matter. Okay. And then what about the minimum and maximum y value? So Ethnan, what's your minimum and maximum y value here?
Minimum is 20.
Yep. Good. Okay. And so Ethnan, what do you think? Can I fit? Are there 100 boxes here? No. So what do you think a good scale would be?
5 would, actually 2 would equal to 10.
Okay, so you can go by tens. Yeah, you can go by tens or go by fives. Yeah, I like that. So, whoops, 5. Go by fives. Okay, so 5 for every box. Okay. Notice your x and y. They don't have to go by the same scale. That's because they are independent and dependent variables. So your x, your independent variable is always your x. So in this case, is the number of hours studying. Okay, and then your y would be grades. Okay. So remember, your independent is always your x. So those of you who took science, you know that you do a lot of graphs in science, and you always have to come up with a title. So what's a good title for this? If I were to plot these points and make a graph, what would you call it? Good. Okay. Yep. So you do want to include these in your title. That's great. All right. What about you? Grades based on our study. So right, both of you use the title of the axis. So what the generic one? The generic one is as Jeffrey said, it's always the y depends on the x. So when you write a generic one, you can say grades versus number of hours studying. Okay. If you write it the other way around, it is wrong because it's not the number of hours studying depends on your grade. It should be the other way around. So the order does matter. It's always y versus x. And if you use that on a science test, you have to be right. All right. So if your science teacher marks you wrong, then you say, no, Miss Ching said it's right. Okay, so this is the generic one that always works. Okay, so now that we have all the info, we can actually make our graph. Okay, let's make the graph. So I have my x-axis, y-axis. Okay, we set to every two box as one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for the y, I start at 20. So does that mean I can write 20 right here? Why not? Right. Okay. So this a common mistake that people do. This is never whatever the first number is. It's always 0, 0. Okay. A lot of people make that mistake. If you were to skip numbers, you have to do a broken line and then like maybe start at 20 like that. Okay. So if you're this number has to be 0, 0. Okay. And then we said to do 5. So 5, 10, and then obviously I don't need you guys to like write every single number. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Oops. Okay. So you don't have to write down every single number as long as I see that you're doing this right scale. Okay. Another common mistake that I always see people do. Okay. I'm doing 1 every 2 boxes. So that means for all of these, it has to be the same. It has to be like every 2 box, every 2 box, every 2 box. You can't be just like, oh, I have more room now. Let me put 10 all the way over here or here and so forth. So it has to be the same. That's otherwise your graph is always going to be wrong. Okay, and then now I can plot my points. 0, 20. It's right on the that right on the axis. 2 and 60. Okay. 4 and 70. 6 and 80. 8 and 90. And then 10 and 100. Okay. So if I plot my points correctly, okay, what type of graph should I be able to draw? A line, yeah, that's right. So in this case, I'm actually going to draw a line. Okay. Like this. Okay, but wait, miss, you forgot this one point. Should I have another line that goes here? No, okay, so in grade 1, grade 2, you know how you guys do connect the dots and then like you make the picture of a dog or a cat and stuff. We don't connect the dots anymore in grade 9. We just draw either one line or one curve. So only one line or one curve. Only. Okay, we only draw one line or one curve. So in this case, I drew a line that goes through most of my point. What about this one then? What happened to this one? Why am I not connecting this point? There's a special name for this point that's like in no man's land. Yep. Outlier. Excellent. Okay, so the outlier means it's not with the rest of the points. It might be just, for example, somebody that never comes to class. Okay, that's why their mark is like this. So technically, based on this trend right here, for someone that doesn't study but just comes to class and listens in class, they should still be able to get 50%. And I always love to use this example. That's why it's so important to pay attention in class. Okay. And if I were to ask you to describe the trend, what would the trend of this be? Positive, good. And what else? Based on like what this graph is about. Okay, good. Okay. I don't even need like the numbers, but in general, you can say the more you study, the better your grades. Exactly. The higher your grades. Okay, so that's the trend. Okay. Uh, okay, so looking at just this graph right here, will I get full marks for this graph? Title, right. So we said right here, grades versus number of hours. Okay, what else? Now do I get full marks? Why not? Right, I still need a title for my X and Y axis as well. Right, so there's 3 titles. This one, and this one. So number of hours and grades. Okay, so don't say I didn't warn you. You guys are gonna get in-class assignment on Friday based on this. So make sure you know how to create these graphs. Not yet, not yet, not yet. I'm still doing my lesson. It's okay. It's right after lunch. You won't thirst to death yet. Okay. Okay. So I'm telling you, on Friday you're gonna be creating a graph, and you guys are gonna get marks on it, and it's gonna be based on something like this. Okay. Uh, this one, oh, sorry, one last thing. These type of graphs are called linear. It has a linear relation. Right? What word do you see inside the word linear? Line, right? This morning somebody said year. Okay? So there's no year graphs, there's a line graph. Okay? So linear, line. You see the connection, guys? All right. So what do you think a nonlinear graph gives you? What do you think I draw if it's a nonlinear graph? I heard it. Yep. That's the next one. So if it's not a line, it's a curve. Right. So for this one, if you did it already, you should see a curve like this. Right, Nikon? Right, Jared? Okay. And then Harshan, what you were saying. Alright, the third type is a scatter plot. What is a scatter plot? Points everywhere, right? So if I have a graph with points everywhere, again, am I doing connecting the dots? No. So I just leave it as points. So no zigzag. No zigzag lines. Okay. So whenever we draw these relations, how many line or curve are we drawing? Just one. Okay. So don't start connecting the dots like a heartbeat. Okay. I'm not looking for a heartbeat chart. Yeah, exactly. Okay. So I want you guys to take 3 minutes. Try example 1 on page 10. Try drawing the graph for page 10. Example 1. Take 3 minutes. Okay. So is there a relation between number of DVDs rent and the cost? Is there a relation? Who says yes, there's a relation between the number of DVDs you rent and the cost? Okay, so if you say there is a relation, that means I can either draw a line or a curve to connect the dots. Okay, but I'm gonna draw a dotted line instead of a solid line. Why is that? Who knows the answer? Why did I draw a dotted line and a solid line on the other one? Right. So if I go into the DVD store, can I say, I only want to watch the ending of the movie? Can I rent half the DVD? Break that disc in half and I just take the right half? No, right? So can I rent half a DVD? No. So that's why it's a dotted line, because it doesn't make sense to have a value for 1.5 or 2.5 or 10.5. So, but as we said, there is a relation between them. So dotted line for when I can't have decimal values, and a solid line when I can. So just like in the last one, can I have 67%? Yes. Can I have 67.5%? Yes. And so that's why I have a solid line in the last one. Okay. Um, for the y, how many of you use this scale? How many of you use the same scale as me? Good. Okay. So if you did, that's smart. Okay, because you recognize that it was just going up by 3.5 everything. So then I could. It doesn't have to be whole numbers. It doesn't have to be 1, 2, 3, 4. It doesn't have to go like from 0 to 5 to 10 like that. If you see a pattern, just do what pattern you see so that you get nice points on the grid. Okay. And then example 2. So we'll just do this one last one, and then we'll call it a day. Given the relation y equals 6 minus 3x, create a table of value. Okay, so in this table, I tell you what to use. So it's -3, -2, 1, da, da, da. Right? If I don't say that and I just say create a table of value, all you have to do is choose your x value. All right, you can choose any x value you want. So we're given the equation. So now what we're doing is we're replacing the x with the value. So who's good at mental math? Zachary, you're good at mental math. So what is 6 minus -3 times -3? Negative 9, and then plus 6.
Oh, plus 6?
Yeah, because two negatives make a plus. So then this becomes 6 plus 9. 6 plus 9?
Oh, opposite that, 15.
15. Good. Okay, so then 15. Okay. What if you plug in -2? So we replace the y equals 6 minus 3x. Replace the x with a -2. Ben, you're good at mental math. 6 minus 3 times -2. Sorry? This is... plus. Remember, two negatives make a plus. So -3 times -2 is plus 6. So 6 plus 6. 6 plus 6, 12. Right. So that means when you sub in -2, you get 12. Okay. Now what if I sub in -1? Replace that x with a -1. Partition? 9. Good. And Zachary, you were going to say when you sub in 0?
Lovely.
6 minus 3 times 0.
Oh, 0.
This part is 0. So 6 minus 0. 6 minus 0.
6 minus 0?
Yeah.
Oh, 6.
Okay. Now, Nicholas, you're good with that pattern. Okay. Without doing any of this, can you tell me the next 3 numbers? Yep. Yep. How did you do that so quickly? No, like so how did you see a pattern? Decreasing by 3. Yeah, that's right. So if you did your math correctly, just like right here, so Zachary used this trick. If you did your math correctly, you should see a pattern in your y. If you don't, if even one of them is wrong, then you made a mistake. Okay, so this is called first difference right here. If the first difference is the same, it means that when you graph it, you should get a line. It's a linear relation. Okay, so if you see a pattern, which meaning that the first difference is the same, you get a line. Also right here, if you just look at this equation right here, what format is this equation? Nathan? Yeah, y equals mx plus b. So if it's in y equals mx plus b form, we also know that it's a linear relation. Right? So just like that, there you go. You figured out how to create linear relations based on the graph. Based on the equation, you can tell it's a linear relation. Based on the table, you know it's a linear relation. Based on the graph, you see a line, it's a linear relation. Okay? And I think you guys are okay with the graph. So if I were to draw the line, so after I've got the points, I draw the line. Should it be dotted or solid? Should it be a so who says dotted line? Who says solid line? Good. Okay, so I should get a solid line. And should my line only go from -3 to +3? I think Afnan just asked me that question. Alright. So should my line, so like my line is like this, should my line be like just like this? This short? No. How should I draw it? Arietta? And what should I have at the ends? An arrow. Yeah. Alright, because your line goes on forever on both sides. I drew it the wrong way, eh? Yeah, my line should go this way, actually. Nathan?
Can I draw it like that if I use X and Y interval?
Yeah, yep, we good. Alright, technically, like that's actually later on when we do different methods of graphing. So, how many points do you need to draw a line? 2, yeah. So right here, I actually have 1, 2, 3, 4, 5, 6, 7. I have 7 points. But later on, we're going to learn to just use 2 points, and then we use those 2 to draw a line. Okay, so that's the lesson for today. Longer than usual, but this is an intro lesson, so I wanted to spend a little bit more time on it. So for the rest of the class, please work on page 12 to 14. Tomorrow, we're going to do the example on page 11 and then page 15.